Swayam Prabha. Digital India. Educated India.
Hi, good morning. Have you gone through the lists? Have you tried to find out different plans' name? Have you tried to understand how the names are given? Do you find it interesting? In fact, I'll tell you, you will get more excited once you start exploring individual trees by its name. And it is, again, I'll take the human analogy. It is if somebody is trying to assess you, then the first reference is your name, and then all your characteristics or traits. Same is for the plants. If you want plant as an element or component in your landscape to be used, then the first thing what you should do is know its name, and then try to explore all its characteristics. So far in the last lecture, I discussed about how to identify the names and trying to at least get a hint of some distinctive characteristics from the second part of the name. I hope this makes it exciting to you. Next thing what you should know is, if suppose you know a name and then you try to know about its all characteristics or attributes. This I will go a little faster, because in my second series of lectures, in which I'll go into the great detail of all these things, but here I should do justice by at least exposing you to all the kind of attributes that we take into consideration for our landscape purposes, because we are discussing about the basic fundamentals. So here it would be, I would say, a tip of the iceberg in terms of what you are learning. In the advanced courses, once we float, at that time you will find there are lots of things will be discussed against each of them. Okay, the characteristics or attributes. You refer that particular list in which I have said the identity or identification, spread, height and all that. Again I will say all these are not written in terms of its priority, but what are these? Let me quickly explain. Spread. Spread you will see with respect to two things. Spread is basically diameter on maturity. Means if suppose, refer to this particular sketch, if suppose there is a tree which has the foliage on maturity, this particular diameter is considered to be the spread. So spread means the maximum extent the foliage reaches at its full maturity. That's a spread. After that what happens is, after that it grows, keeps on growing, but this spread doesn't change much. So I am very much concerned about this dimension whenever I am selecting this particular tree to be located in my landscape. So when you are saying this spread, I will also like to draw your attention to one particular point in terms of two forest phenomena. One is called dominance and another is called adaptation. Okay, these two I will come to, but before that there is one more thing. So the tree is not necessarily just merely a kind of trunk and the foliage. It has also a root. So whenever, let me discuss here itself, even if I am going to go to the root structure, I am also concerned about, when I am thinking about the spread, I am also concerned about the spread of the roots, how much extent this is going to go to. The thumb rule says, I will tell you, there is almost no document which has made substantiated confidence in me saying that okay, the roots for this tree is of this spread. I did not find. Maybe someday I will find it, some research, or maybe if any one of you know, please forward me that particular sources. But there is a thumb rule. We always take it as a thumb rule that if a tree is fully grown, then it is always advisable or safe to take 1/3 more than that means about say 1.3 times. If this is x, then take the root spread as 1.3 times of the x. That means root is more wider. Why this is safe? Because you don't know what's going to happen below the ground. You can see this part, you can trim it, but this you cannot trim. You can, but the thing is not regular. This you can trim and bring it to a shape if it is conflicting with other functions, but here it cannot. So it is always better that if you know the spread of a tree, which you can do it, just very simply, that you take a team of experts and go and measure the same species and the same age of the same locality and keep on measuring the spread, and then you take an average of it. You will find that this x will be known to you. Fine. And just as a thumb rule, take 1/3 more than that as a spread of the roots. That's safer. And what is the dominance and adaptation is, I'll discuss this later in one of my second series lectures. Let me just introduce to you, it is very important. The trees, this different plants, they have their intrinsic power. Okay, that particular power by which it extracts water from the soil, it transpires, it spreads its branches and takes position in the reality. Okay. Now, if suppose there is a situation where you have, suppose there is one tree here and there is, let me draw it this way, you have planted a tree which is of this shape. Actually, another thing, let me tell you, in general, whenever you are trying to represent a tree, we always represent like a globe or like a circle. Most often in plan, always a circle, because we hardly found any tree which looks like this, hardly, unless we trim it and deface it. Okay, so most often it is this. And suppose you have planted 3 trees one after another, and the tree which is likely to grow in its full mature shape is like this. This will give you a good idea about what dominance and adaptation I am talking about. If suppose now in this is species A and this is species B and this is species A. If A is a dominant species over B by its own intrinsic strength, then what will happen? A will try to grow to its full maturity spread. B will be now restricted or constricted in terms of growth. So what will happen is, there will be some bit of adjustments at this particular point, but A will grow to its full matured spread and B will be restricted to its full, not to this, and this A will grow to its full matured spread. This is the phenomena which is found in the forest, which is called dominance. Now the question is, if suppose now this is A and this is, all 3 are A, this is A, this is A and this is A, then what happens? Interestingly, just like human culture, human system, they will be adapting to themselves, they will adjust. What will happen? There will be a central line coming, this will be a central line. If you really measure, it will be almost central line, and this tree will grow to its shape like this. This tree will now adjust to this dimension, this tree will adjust to this dimension. Very interesting phenomena. This is what is called adaptation, and this is called dominance. This dominance and adaptation, these two phenomena, don't disregard it. You be very, very sensitive about it, and whenever you are planting different species one after another, the best option is you plant them independently, consider each of the spread as the dimension and keep some allowances for some kind of uncertainty of growth. What I mean to say by that is, if suppose this is A, which is at this point this, and which is likely to grow to this size, then I would say let your B be allowed to grow to its full matured shape, and then another A which is here. Now there is no conflict, each one of them will grow to its full matured spread, not only spread, even the height. Now in such case, and then additionally you keep some allowances or clearances between these two. You are safe, trees are safe, trees are not disfigured. This you take note of. Okay. So what happens is, if suppose now I say that what will be the spacing between these two, and if this is, that means it is the spread of A by 2, spread A by 2, spread B by 2 plus say 1 to 2 meter in between, let us say 1 meter. So, your spacing between these three will be SA by 2 plus 1 plus SB by 2. This is the spacing between this and this. Is that clear? Is that clear? If you do this, you find that you are in safe situation. But at the same time, let me tell you, every kind of experimentation we can do, I can deliberately create this. If I want that the bee to be disfigured, then I will deliberately place them in between in a constricted position, so that bee is not allowed to grow to beyond this limit. But what happens if it is reversed? A is dominant, it is in the center, then the bee and the bee. This also you need to know. Okay. Then what happens is the bee will grow to its full matured shape, and now A will be restricted. This is what is going to happen if suppose B is in the center. That is, this is B, sorry, this is A, dominant one, this is B and this is B. In that situation, this is what is going to be. And not only it is here, you know what happens is tree always tends to grow upward. Okay. In this kind of situation, you know what will happen, the spread has been delimited by the dominance factor, but the height is free because it is clear upward. So, the tree which was supposed to be growing to this height, which was supposed to be growing to this height, will now after restriction will become slender, because the height is there. So, this height they will reach. This is how you should always see this particular kind of spread. Okay. So, as I said that it is going to have a differential variations in spread. So, similarly the root spread, which I just now discussed. So, the thing is, you take care of this spread in full maturity, also the root spread in full maturity, and then decide what should be the placement of this tree. Then comes height. You know, height you should see in this way. For a tree, take its full matured height, this height. Take note of this as a full matured height. Okay. That in total full maturity, what is the height? This is what is the height that you are referring to, but there is another height that you have to take into consideration when you are designing. That is this height. This is what is the clear trunk height. So, this clear trunk height is the height which is from the root collar to this soffit part of it. Okay. Now, take note of the height as well as the clear trunk height. Then comes the form. Form is basically, or profile, you know, let me call it profile, it will be better, profile. Let's change this. We will call this as profile, not form. Okay. Profile. In this, basically what is this profile? Profile is when you are looking at a tree against a lighted background. See, tree has lots of different kind of textures, you know, irregularities and all that. When you are looking at it from a distance, you look at the trunk, you see a trunk, a stick and then a globe above. Now, when you are looking at this against a lighted background, you see this as a dark patch, dark image, and that is what is a silhouette image of this, and that represents a profile of this. There are different kind of profiles which are here. It can be broad, square, round, fan like, tapering, conical, columnar, umbrella. Let me try to give a very quick idea about. Say if it is something like this, it is broad. If it is something like a little of this, it is square. If it is something like this, a round. If it is something like fan. If it is tapering, if you have this and very sharp conical, if you have this like columnar. If you have some tree which is like this is umbrella. I'm just trying to generate different forms, and point is what name will you give and what is the kind of profile that you are representing this, that's purely up to you. You can always have your freedom in it. It is nothing like a sacrosanct one that this is has to be said in that form, but usually it is representing that. Okay. Then comes a root structure. Root structure, it's a very essential thing which I just now said. It makes a lot of difference in our plantation things. There are different kind of roots, but let me explain to you slightly more in detail, because see, for other parts of the plants and all, you are aware, but the roots, it needs a little elaborate discussion quickly. Whenever you look at the root of a tree, see, now if I draw one more thing, that will be good. There is if I draw a single line diagram of a tree, then it is a single line diagram. This single line diagram you follow and try to understand. This is the ground line, soil line. This part is called roots, and this part is a shoot. Of this part is the root collar. This is the trunk, central leader, and this one is other branches, stems. Then we have a leaf, and then we have, wherever it is branching from, there is a bud. This particular point where it is branching from is called node, and the intermediate zone between two nodes is called internode, and then the bud from which the stemming really starts is called the axillary bud, and then at the end of each of this branch you have a bud called apical bud or terminal bud, and then in this branch you have a leaf, and you also have a flower which is called inflorescence, and also you have a fruit. Okay. If you really see, this is a very sketchy diagram of any plant of any form. So it has a root, it has a shoot, it has central leader, it has the tap root, it has the secondary roots. That's how. So now I'm bringing back to this root structure. Basically, there are three such roots. One is a primary root, and is a secondary root, and tertiary root. What is it? It is this. Let me draw it here. If suppose there is a tree and then you have a root which is going like this, it's a primary root. Whatever comes from this edges, whichever direction, this is a secondary root, and from there again whatever roots is coming is the tertiary roots. Tertiary roots also will have tertiary roots and tertiary roots and tertiary roots. Okay, this is how you try to view the roots. Now the roots will have different kinds. Say one is the tap root which goes direct. Another is a lateral root which is primarily going to the sides. Then we have the fibrous roots. When the tap roots and the secondary roots, the primary roots and the secondary roots, or tap roots and the lateral roots are almost of the equal strength and equal size, then it becomes a fibrous roots. Okay, and when you find that in some cases when the root is very much going deep into it, then it is a deep tap root, and then you might find sometime the root is also it is coming from here and also going above the ground. As I said, the Starculia alata example, this is called buttress roots. I'll go a little more detail in this in my next slide. And then parasite roots is basically when it is trying to grow from the other branches. They are parasite roots. Adventitious roots are basically they are roots which are it grows in a different directions from different parts of the shoots and all that. Okay. The storage roots are which one where we have a fleshy or say tuberous kind of thing which is slightly voluminous. Then contractile roots are bulbs which looks very big, but if you press it, it almost gets pressed like this, so it contracts by this. The prop roots are one which grows from the stems and ultimately leads to the soil, like banyan tree, where it is something like where it will start from these branches and it will generate from there, then ultimately fall and ultimately get hooked to this soil. This is all this banyan trees situation that you have seen. They are all prop roots. That adventitious roots that you will see that it comes from the stems. If you see that even Ficus elastica will have the roots. If you look at the tree, suddenly you realize that their roots are coming from the stems or the branches. They are there, and the aerial roots are epiphytes, which are growing again from the stems, and the pneumatiferous roots are oxygenators, which does not require soil. So all those roots which are in the water are this pneumatiferous roots. I'll just show you one more picture in this, which will give you some idea that in this case what happens is, you have, just see with respect to this sketch, pay attention to this one, it is numbered. See, any roots which are going vertically down are the vertical roots, any roots which are going horizontally towards like this is the horizontal roots. Okay, and this particular junction of the trunk and the roots at the intersection of the soil is the root collar. Then number 4 is the trunk, this is what is the trunk, and the 5, all these are stems. Okay, and the number 6, this particular part is called central leader, and then these are main branches, and the other ones are small are lateral branches. So when you look at the entire tree profile, which I tried to give in a very schematic manner in a single line diagram, you will find in this I did not put all those apical buds and all, because it's too complicated drawing here already. So now what we will find that at every end of this lateral branches there will be an apical bud. Now apical bud is responsible for the tree's growth. If suppose you want to impede the growth, stop the growth of this, you cut the apical buds. Means you cut the apical buds, other branches will come, there will be apical bud, you keep on cutting, what will happen, the branch tree will start getting restricted. That is how through this pruning topiaries and all these things are created. Okay, now some more. In the primary root system you have this profiles. I am not going to discuss much on this because I am putting this on a slide like this, but still they are classified something like this. Like if it is taproot like this, is a taproot weakly branching, that means branches are very weak. Number 2, if you see the deep branching taproot, that means taproot comes quite below and then after that it branches. Number 3, more branching taproot, that means you have the taproot and the secondary roots almost in the similar nature. So if it is more branching taproots, this might ultimately turn out to be fibrous roots. Superficial taproot, in which this is a taproot but there are many other secondary roots which are equally strong. Superficial tap anchoring roots means this particular taproot and after that the other secondary roots will have anchoring here. And then in number 6 is superficial anchoring roots, in which the taproot almost non-existent, the secondary roots are very strong, and then we have the anchoring. Then we have the palmate roots, it looks like palm leaves, like these roots are going in the palm nature. Then we have superficial root, in which the taproot is almost negligible. Superficial taproot with ascending coralloid roots means here multiple such roots, as like corals, they almost start growing against these roots. Why all these are superficial? Wherever the taproot is almost missing. Okay, now here superficial root with aerating roots, in such case what happens is that secondary roots are very strong, taproot is very weak, and then there are aerating roots which are popping out of the soil. It's just like banana tree, if you see that roots, and from there the tree grows. There are many such cases, and many of the trees like say something like say mango tree, similar nature, where the roots is going to grow from the secondary one and ultimately becomes a shoot above, and then you can take it out very carefully out and ultimately grow another mango tree somewhere else. And superficial root system with buttress roots, in which the taproot is almost missing, but the roots are growing above the ground, the buttress, the one just now I said here in this particular sheet as an example. Okay, so these are different about roots. Now let's see about the foliages. In foliages we have, what you have to check is foliage is which part I am talking about. It's this part of the tree, not considering the trunk part of it, this part of the tree. What are the things to be seen in this is the overall foliage, then evergreen or deciduous, that means it has leaves all throughout the season, throughout the year, or it sheds these leaves intermittently for different seasons. Then what's the density, that what number of leaves within that volume. Then layering, how are they placed over each other. Then distribution means here notice it that there could be two situations. I am just drawing very quickly on this. Either the leaves are all uniformly distributed all over, or it may be the leaves are all distributed over the surfaces. Okay, this distribution is very important. it is important in terms of solar interception, solar radiation interception and all that. But however, you are trying to know about the foliage. Are they uniformly distributed? Like Mimosup's elengi, bakul tree, in which they are very uniformly distributed. And here, like this, a tree called Samania saman, in which you have all those as peripheral. So how it is distributed over? Are they clumped and structured, just like Alstonia scholaris, in which the leaves are clustered, clumped together? Are they variable, irregular, or are they peripheral? Something like, say, what I am saying here, like, say, are they peripheral on the surfaces? And then comes the leaf pattern, whether it is simple leaf or compound leaf, what's the size, what's the shape, what's the edge, and what's the color and texture. Today I will, in this discussion, I'll just introduce you to this. In my next series, I would advise you to join my next series of lectures, in which there will be lots of details which I'll be discussing about this, because if I start discussing the details in this, you lose the actual path. Okay? But when we are thinking about the leaf pattern, what we are seeing is this, whether simple or compound or size, what's the size of it, what's the shape of it, what's the edge, color and texture. I'll just give you few examples, quick examples. The leaf profile is this. They have different names, scientifically developed, and they are unique. And any leaf that you see, if you compare with this, you definitely can make out that which leaf is what type. Okay? Subulate, acicular, filiform, linear, oblong, elliptic, ovate, ovovate. Then you have lanceolate, oblanceolate, spatulate, orbicular, rhomboidal, deltoid and reniform. These are different profiles. So each leaf is of different type. Each leaf means each plant's leaf is of different profile. And I'll tell you all these profiles together, profiles and the size and the texture and the age together, if you now combine all these attributes of a leaf, that makes the whole foliage. So ultimately the attribute of the foliage is contributed by these. So you have to be really knowledgeable about it, try to know about it. Some more in terms of profiles. Here the profile is differently explained. What happens is this, let me explain. You should not think that the leaf which is like this is of this form. Always try to see what is the profile of the top part of it and what's the profile of the bottom part of it. And this is where it is explained here. So there are different kind of nomenclatures for the top parts and the bottom parts. Okay? See here, acute, acuminate, aristate, cuspidate, micronate, mucronate, obtuse, retuse, emerginate. If you see the lower part, cuneate, attenuate, obtuse, caudate, auriculate, sagittate, hestate. If you see this oblique, now what happens is, see why this knowledge is important. You might find a leaf which has the top part as, let's say, like retuse. Top part is like retuse. What is the bottom part? Bottom part may be caudate. Just take this picture, follow this picture, bottom part may be caudate. So when I am looking at it, what's the actual profile? This particular profile does not match with my this anyway. So we have a combination of such profiles in which you have to now know. But let me draw your attention to one more information. That is, this is retuse. This is the retuse part of it. This gives rise to another nomenclature of another ficus group, that is called ficus retusa. Now how would you differentiate between ficus retusa and ficus religiosa? You should know that even if they are ficus group, but the retusa tree must have a leaf which is the top part is this. And what is the religiosa's people tree leaf like? People tree leaf, if you remember, it is like this, isn't it? Okay, if this is so, then the tip is this, then the religiosa's top part is aristate and religious's bottom part is cordate. That is how you should know about the leaves. Okay. Let me go forward quickly. Also, there are certain things called edges. So, leaves, when you are seeing, you are also seeing with respect to the edges. Edges in terms of entire means very clean, clear, or it is sinuate, slightly curly, or crenate is slightly more irregularly curly, or dentate, like almost sawtooth like, and serrate is like sawtooth like, and cerulate is very sharp sawtooth like, and doubly serrate is, it's a mix of this. If you now start going through all these things, when it comes to parted, means there are, say, papaya leaf. If you remember, the papaya leaf is something like, it's this, or maple leaf is something like this. It is parted. Okay. So, every such identity of the leaf of different plants have something to offer in terms of its visibility, in terms of its existence. So, when you are seeing this, take note of it. Quickly going through the others. In terms of branching habit, horizontal spreading, angular branching, I will just explain what it is very quickly. See, horizontal branching is basically if a tree is growing horizontally. This is horizontal branching. Angular branching is if the tree is growing in angle like herringbone. Okay, fan like is if the branching is of this nature. Fan like. Arrowhead is if suppose it is like like this. Okay, umbrella is if the branching is of this nature. Weeping is if the branching is like this nature. Contorted is if the branching is absolutely irregular. If you follow this, this is horizontal spreading, this is angular branching, this is fan like, this is arrowhead, this is umbrella, this is weeping or drooping, and this is contorted. So, now one thing keep in mind, there is no correlation between the branching pattern and the foliage profile. No, there may be a contorted branching pattern with a very regular profile. So, do not get disturbed by that. Okay. The next few points in terms of growth pattern, we take care of the qualitative, fast, medium and slow growth, or quantitative in terms of growth per year or maturity period. And in terms of soil tolerance, we check with the physical properties of texture and the structure of the soil, which I have discussed earlier, and the chemical properties in terms of acidity, alkalinity, salinity or organic components, because that makes the plant's survivability with respect to the soil chemistry and soil structure. The physical properties like texture and structure is for roots holding, and the chemical properties are for essentially nourishments. In terms of light requirements, sorry, it came in a different form. In terms of light requirement, what is the minimum light requirement and what is the photoperiodism, means how much time of the day it should get the light, and the phototropism means if it does not get the proper light in that direction, then it tends to bend towards that. All these I will discuss in my next lecture, because I am just introducing you to this. Temperature tolerance in terms of, say, extreme temperature, optimum temperature and winter desiccation, that has to be taken into consideration. In terms of water requirement, with absorption coefficients of this, water intake or movement that is through the tree, and the transpiration rate and the relative humidity and transpiration index. Okay. Relative humidity of the stomatal cavity, that is going to be taken care of. In terms of bark character, the texture, color and the utility. In terms of cattle proneness, leaves, barks or wood, what is being attacked or attracted or attracting the cattle. In terms of susceptibility to the wind flow, which I discussed already, slenderness ratio, root structure, root strength and the branch strength. In terms of flowering attributes, various things: size, shape, density, color, texture, flowering season, flowering duration and fragrance. Wait for my next set of lectures, and I will go into each one of them with samples and examples and explain scientifically what is what. Okay, it's just the intro, basic level. In terms of fruiting attributes, size, shape, color, texture, fruiting season, edible or not, or is it hazardous? In terms of pollution sensitivity or pollution resistance, there are, from the researches or resources, I have found out some of the plants name in that list. I am not very sure how substantiated it is, but still, since I have got a published report, so I am just pressing it to you so that you have in your stock. But these are the common plants which we get in our country, in India, which are pollution sensitive, and these are pollution resistant. Okay. And then termite resistant plants, this data I have got from the Forest Department, Forest Research Institute in Dehradun, and I have noted down from there, and I found out that they always classify this as class 1, class 2, class 3, class 4 and class 5 as the termite resistant plants, and they are all common plants under this. So, if suppose you are going to make a landscape in an area which is highly termite infested, then these are the trees which are very resistant. So, your selection will be very automatically very easy to take this data into consideration. But always I will say that you search for the best possible resources, which I am always constantly trying. And then another thing is utility in or applications in terms of these, whether it is shading utility, canopy, backdrop, physical barrier, visual barrier, separator, guiding view or orientation or accentuation. Sorry, accentuation came twice. Ornamental, ground cover, dust or noise interceptor, medicinal, household or fuel, building construction, erosion resistance. So, when you are looking at the utility of the applications of the plant materials, you are seeing with respect to this. Wait for my next lectures. In this, all details will be shown with examples. This brings me to the end of this series of lectures of the basics and fundamentals. I have just given a very brief bibliography here, but I can tell you, if you can get hold of these books and read it through, you will be highly benefited. Many of my points which I have brought here, they are referred from this particular book, but altogether, if I really be frank with you, maybe more than 300 books on landscapes and all other aspects with drainage, landform and other aspects, rendering of landscape, all these I have studied, and my research team is constantly working and they are doing PhDs under this. Okay? So, this bibliography is not enough, it is just few which are in front of you. If you read this, my first point is, if you read this, you get a good amount of idea. But be interested. My focus of or purpose of giving this particular lecture or offering this at the national level is essentially to make people interested in the landscape and site planning. But I will tell you, this is only the tip of the iceberg. So, what we have learned is the basics and fundamentals with respect to this. What lies ahead? Let me just give you that intro. What next in future? Most likely, I am not very sure, but most likely it would be floated in the month of August. If my lectures have created a bit of interest in your mind, you share this with your friends and families, make them interested, try to learn more through my next level, that is advanced application, in which I am just giving a menu of it, that what all are likely to be discussed. There are plant science and maintenance. In this plant science and maintenance, I am going to discuss whatever I did not discuss here. I kept it for the next level, where I will go deeper into it with all plantation sciences, and then the real way how you should handle in the landscape projects, that will come. Okay? Stormwater management, which I deliberately kept it in the next section, so that I can do justice with the detailed engineering aspects of it. Indoor landscape, terrace landscape, residential landscape, park planning, avenue landscape, bonsai plantation, desert landscape, environmental control, forest recreation landscape and brownfield landscape. If you now go through this, you have gone through the first set of lectures of 8 weeks. If you now go to the next set of lectures for 12 weeks, I am very confident that you will have a very good idea about the entire landscape process and the subjects. How you imbibe it, how you extend your knowledge beyond this, and how you practice it, it's up to you. But I'll be very happy if suppose people who have registered for this particular course, I'm very thankful to them that you have registered and you have taken interest to learn this particular course, and this is a never ending study. So, in my next set of lectures in the part 2 in advanced application, when it will be through, from then on I would advise you that you can always be in touch with me and try to know more and more and more. I will be very happy to communicate with you, and you can always shoot a mail to me for any further clarifications. Thank you very much for joining this course. All the best.